Hello everybody, welcome into another lesson. So today we are going to talk about the quotient of complex numbers. That is going to be where you have a complex number in the denominator of a fraction. Now these can take many forms, but for example here you have a general 1 over a plus bi. If we remember back to real number radical expressions with real number square roots, it's not considered to be in standard form if you left a radical in the denominator. The same is true with complex numbers because I is the square root of -1. Now, we have to do the same as with real number square roots. You have to rationalize the denominator in order to get this into standard form. In order to do that, you're going to multiply both numerator and denominator by what's called the complex conjugate. So if your denominator is a plus bi, you would multiply both numerator and denominator by a minus bi. So why don't we work that out real quick? Let's multiply both by a minus bi, right? So we do that, you'll end up getting a minus bi in the numerator, and then you can clearly see this is going to be a difference of two squares, which this will be every time when you multiply by the complex conjugate. You would end up getting a squared minus bi squared, which would end up giving you a minus bi over a squared minus b times -1, which would end up giving you a minus bi over a squared plus b. And notice you no longer have the I in the denominator. So to write this in standard form, you're going to take a over a squared plus b. In this case, you would take minus b over a squared plus b times I. That's how you would write this in standard form. That's just general. It's usually not this complicated. This is just the general form. So this also, and I'm going to show you an example that it's going to seem like the easiest, but it's actually probably the hardest one. We're actually going to start with the hardest one first. So let's say, for example, here you have something that looks as simple as 1 over I. You want to get the number in standard form. This is 1 over I. A lot of people think, well, I is just the square root of -1. If it's just a square root, you would multiply both by the square root of -1, which would just be I, the numerator and denominator. This isn't like conventional square roots, though. This isn't like you have 1 over the square root of 2, where you would just multiply both numerator and denominator by the square root of 2. We have to remember something. What is I? I is the same as 0 plus I, right, in standard form. So what would the complex conjugate of I be? That would be 0 minus I, or simply put, -I. The complex conjugate is actually -I in this case, so why don't we multiply both by -I? So you have to multiply by the complex conjugate when it comes to complex numbers. So you're actually going to multiply both numerator and denominator by -I, which would turn into -I over -I squared, which would be -I over -1 times what is I squared. That's also -1, which would be -I over +1, or simply -I. So 1 over I in standard form would actually just turn into -I. And I used to get that wrong all the time myself, but remember, with complex numbers, they're not conventional square roots. Yes, you have to still rationalize the denominator, But always remember to make sure it's by your complex conjugate, not by just the simple I. Okay, let's get into some examples here. So this time I have 8 over 1 plus I. Let's say I have 8 over 1 plus I. I want to get this as a complex number in standard form, which is definitely not, since you have a complex number in the denominator. You can't have that. So first identify what is the complex conjugate of 1 plus I. That'd be 1 minus I, right? The complex conjugate would be 1 minus I. So now I need to multiply both numerator and denominator by 1 minus I. So if I do that, well, 8 times 1 is 8, minus 8 times I, so you get 8 minus 8I in the numerator, and then this will just be a difference of 2 squares. You get that over 1 minus I squared, which would turn into 8 minus 8I over 1 minus that I squared, which is negative 1. So this would turn into 8 minus 8I over 1 minus negative 1. That'd be 1 plus 1, which would mean this would be 8 minus 8I over 2. And both of the numerator terms factor by 2. This would just become 4 minus 4I. So the number in standard form would actually be 4 minus 4I. So always remember to rationalize your denominator with the complex conjugate, and remember that I squared has a value of negative 1. That's how you'll succeed at doing these. Alright, next. So we have 2I over 1 minus I. So we've been given 2I over 1 minus I. Well, we have a complex number in the denominator, which once again we can't have. So we have to rationalize the denominator. In order to do that, we have to multiply by the complex conjugate. And the complex conjugate of 1 minus I would be 1 plus I. So 1 plus I is the complex conjugate. Now let's go ahead and multiply both numerator and denominator by that complex conjugate of 1 plus I. Alright, so in the numerator, if you distribute, you would get 2I plus 2I squared all over, this would become a perfect square, so that'd be 1 minus I squared. So this is going to be equal to 2I plus 2 times that I squared, which would really be times negative 1 over 1 minus, what's I squared? Negative 1. So this would become 2I minus 2 over 1 plus 1 is what? 1 minus negative 1 is 1 plus 1. So why don't we go ahead, put the numerator into standard form, which would be negative 2 plus 2I divided by 2. Both terms of the numerator divide evenly by 2, so you'll end up with negative 1 plus I. You end up getting a complex number in standard form of negative 1 plus I. That would be your answer. Alright, let's see. Negative 5 minus 3I all over 4I. So you have negative 5 minus 3I over 4I. Well, we need to identify what the complex conjugate of 4i is. That's going to be negative 4i, actually. So negative 4i is your complex conjugate of 4i. So now multiply both numerator and denominator by that negative 4i. Alright, so let's distribute negative 5 times negative 4i. That's going to be 20i minus 3i times negative 4i. That'd be plus 12i squared. This is going to be all over negative 16i squared. So let's simplify this sum. So 20, you'll have 20i. Whoops, make sure I write the I, that's very important. Plus 12 times what is I squared? That's negative 1. All over, then you have negative 16 times what is I squared? That's negative 1. Which would end up giving you 20i minus 12 all over positive 16. Which we need to write the numerator now in standard form. This would end up giving you negative 12 plus 20i all over 16. Well, everything in the numerator and denominator has a common factor of 4. If we separate these terms, negative 12 over 16 plus 20 over 16i, we can divide everything evenly by 4, which would give you negative 3/4 plus 5/4 I. So the complex number in standard form is going to be negative 3/4 plus 5/4 I. That's exactly what you'd end up getting. Alright, so let's see. We have 3 plus I divided by 3 minus I. Alright, so 3 plus I divided by 3 minus I. So in the denominator being 3 minus I, we need to multiply both numerator and denominator by the complex conjugate in order to rationalize the denominator. The complex conjugate of 3 minus I would be 3 plus I. So now go ahead and proceed to multiply the numerator and denominator by 3 plus I. Alright, so let's FOIL the top. 3 times 3 is going to be 9, plus 3 times I, plus another 3 times I, plus I squared. That would all be over a perfect square, which would be 9 minus I squared. Well, let's simplify the numerator. This would turn into 9 plus 6i. Now, what's I squared? That'd be minus 1. All over 9 minus I squared, so that'd be minus negative 1, which would be equal to 8 plus 6i all over 10, which everything divides by 2, so 8/10, that would be 4/5 plus 3/5 I. So the complex number you would get in standard form would be 4/5 plus 3/5 I. I have about 4 more. So we have 2 plus 5i all over 5 plus 2i. So we have 2 plus 5i all over 5 plus 2i. Well, we want to rationalize the denominator, so what do we have to multiply the numerator and denominator by? It's complex conjugate. What is the complex conjugate of 5 plus 2i? Well, that's going to be 5 minus 2i. The complex conjugate is 5 minus 2i. So now, go ahead and multiply numerator and denominator by 5 minus 2i. So let's do the foiling of the top. 2 times 5 is 10. 2 times negative 2i, so that'd be minus 4i. 5i times 5, that'd be plus 25i. And then 5i times negative 2i, that'd be minus 10i squared. This would all be over the bottom, which will be a perfect square, would turn into 25 minus 4i squared. So let's simplify the top. You would end up getting 10 plus 21i minus 10 times that I squared, which is actually negative 1, all over your denominator. 25 minus 4 times what is your I squared? That's also negative 1. So this would turn into 10 plus 21i plus 10 all over 25 plus 4. So this would turn into, in the numerator, 20 plus 21i over 29. And then simply put, for the complex number in standard form, you would have 20 over 29 plus 21 over 29 times I. That is going to be the complex number in standard form that you would get. 20 over 29 plus 21 over 29 times I. I have about 3 more here. All right. We have negative 7 plus 6i, all that divided by 9 minus 4i. So we have negative 7 plus 6i over 9 minus 4i. Well, we need to rationalize the denominator by the complex conjugate. The complex conjugate is of 9 minus 4i would be 9 plus 4i. So we'll multiply both the numerator and denominator by 9 plus 4i. So let's go ahead and do that right now. So 9 plus 4i over 9 plus 4i. All right, let's FOIL the top. Negative 7 times 9 would be negative 63. Negative 7 times 4i, that'd be minus 28i. Then 6i times 9, that'd be plus 54i. And then 6i times 4i, that'd be plus 24i squared. This is all going to be all over. We have a perfect square now in the denominator. This would be over 81 minus 16i squared. Alright, so in the numerator, let's simplify this a bit. You'll get negative 63, negative 28i plus 54i. That's going to be plus 26i. Plus the 24 times what is the value of I squared? That's negative 1. All over 81 minus 16 times what is the value of I squared? That's negative 1. So that's going to turn into negative 63 minus 24. That would be negative 87 plus 26i. All over 81 plus 16. That's going to be 97. And from what I can see here, none of this factors out very well. So all you're going to be left with then is negative 87 divided by 97 plus 26 over 97i. That would be the complex number in standard form. Negative 87 97ths plus 26 97ths times I. And I have about two more. Alright, so let's see. We have the square root of 10 all over the square root of 10 minus I. This one, it looks like they're trying to trick you. But in this case, wherever you start, the I will dictate. Your I dictates your complex conjugate. So we want to rationalize the denominator. You have the square root of 10 minus I. Your complex conjugate is going to be the square root of 10 plus I. So now you're going to have to multiply both numerator and denominator by the square root of 10 plus I. Alright, so distribute in the numerator, you would end up getting 10 plus that I times the square root of 10 all over your denominator, which would end up being a perfect square. You just end up getting 10 minus I squared, which will simplify into 10 plus I times the square root of 10 all over 10 minus, what is that value of I squared? That'd be negative 1. So you would end up with 10 plus I times the square root of 10 in the numerator over your denominator, 10 minus negative 1. That would turn into 10 plus 1, which means your complex number in standard form will be 10 over 11 plus the square root of 10 over 11 times I. So that is your complex number in standard form, 10 elevenths plus the square root of 10 over 11 times I. And I got one more. Alright, so we have 6 minus I times the square root of 2 over 6 plus I times the square root of 2. Okay, so we got 6 minus I times the square root of 2 over 6 plus I times the square root of 2. Well, we want to rationalize the denominator, so the complex conjugate of 6 plus I times the square root of 2 would be 6 minus I times the square root of 2. So yes, it always helps to identify your complex conjugate first. So now multiply both numerator and denominator by that 6 minus I times the square root of 2. Alright, so let's do the foiling in the numerator. 6 times 6 is 36. This would be minus 6I times the square root of 2, minus another 6I times the square root of 2. And this would be simply plus 2I squared. This is going to be all over. Now you have a perfect square, so this will be 36 minus 2I squared. So let's simplify this further. You would get 36 minus 12I times the square root of 2. And then plus 2 times your I squared, which is negative 1, all over 36 minus 2 times what's your I squared? That's negative 1. So this would turn into, in the numerator, 34 minus 12 times I times the square root of 2, all over 36 plus 2, which we'll just say 38 for simplicity's sake. Well, good news is everything divides evenly by 2. So for the real number part of the complex number, 34 over 38 reduces to 17 over 19. Minus, let's see, 12, let's see, that would be 6 times the square root of 2 over 19 times I. So the complex number in standard form would be 17/19 minus 6 times the square root of 2 over 19 times I. So that is how you write the quotient of two complex numbers as a complex number in standard form, by rationalizing both numerator and denominator by the complex conjugate of the denominator. So that's it for this lesson. Next lesson we will find the absolute value of a complex number. So I hope everyone has a great day. Take care.